Hello students, today we can discuss the topics of second unit, unit 2, theoretical distributions. Theoretical distributions. In this unit, we are going to discuss some defined discrete distributions and continuous distributions. Topics you please note down. Discrete distributions. Second one, binomial distribution. Fittings in binomial distribution. Third one, Poisson distribution. Fittings also. Fourth one, geometric distribution. Geometric distribution, memoryless property. Fifth one, continuous distributions. In this continuous distribution, we are going to see uniform distribution, Seventh topic, exponential distribution. And thus we have memoryless property. Last topic, normal distribution. So in discrete case, we are going to discuss three distributions: binomial, Poisson, geometric. And under continuous distributions, we are going to discuss three more continuous case distributions: uniform, memoryless, and uniform, exponential, and normal distributions. Today we can see binomial distribution. Before of that, discrete distributions. The distribution functions we defined for both discrete case as well as continuous case random variables. So here the discrete distributions means the distributions defined by using discrete random variable. Okay, first one, binomial distribution. A random variable capital X. Random variable capital X is said to follow binomial distribution if it assumes only non-negative values and its probability mass function. Why? Because x is here discrete, so we can write it as probability mass function is given by P of x equal to ncx p power x q power n minus x. X it takes values 0, 1, 2, 3 up to n only. Here n is total number of trials. X is number of success. So whatever we expect as success, we can take it as x. So that obviously we can understand n minus x is nothing but number of failures. P is probability of success. Q is probability of failure. If we repeat capital N times, suppose if we repeat capital N times, the small n trials are repeatedly come, then by using the rule you can write it as P plus Q equal to 1, so that the function f of x into capital N is the frequency of the particular random variable x. So that this many times we can get for the particular case of a random variable. So here we can write it as n into ncx p power x q power n minus x. X it takes values 0, 1, 2, 3 up to etc. n. This is the definition of binomial distribution. Here each trial results in two mutually disjoint outcomes termed as success and failure. Example, the number of trials n is, here in number of trials n is finite. Okay, and the trials are independent of each other. Probability of success P is always constant for each trial. These are all the assumptions. Example, we can say that finding the male birth in a family. Why? Because male or female, two categories of birth we consider in generally. It has many applications, quality control measures and sampling processes in industries to classify items as defective or not. Medical applications as success or failure of a surgery, cure or not cure of a patient, like the things we can say as examples. Here we need to derive the mean, variance and standard deviation by means of moment generating function. These derivatives are very important. Now we can derive the thing. You write it MGF, mean, variance and standard deviation of binomial distribution. BD means binomial distribution. Here we can start with MGF. MGF formula mx of t, that is equal to E of e power tx equal to summation over x equal to 0 to n e power tx p of x equal to x. So that we can replace probability function x equal to 0 to n e power tx ncx p power x q power n minus x. X varies from 0 to n. When we expand the summation, it will become, we can combine the same power, summation x equal to 0 to n e power t p whole power x ncx q power n minus x. Now we can expand it by substituting x values. When x is 0, anything power 0, 1, so q power n comes simply, plus nc1 p e power t q power n minus 1 plus nc2 p e power t whole power 2 q power n minus 2 plus etc. The last term p e power t whole power n. This is a finite expansion series, finite binomial series. It can be written q plus p e power t whole power n. The general formula I write it here. A plus b whole power n equal to a power n plus nc n minus 1 or 1. B a power n minus 1 b plus nc 2 a power n minus 2 b squared plus etc. plus ncn. Simply this is 1 only, na? So simply we can stop it as b power n. Okay, this formula we apply to get the answer q plus p e power t whole power n. By means of this MGF, we can derive mean and variance. First, we can write it as mx of t is nothing but q plus p e power t whole power n. This is what do you know? MGF. Mean mu1 dash. This is mx dash of t with respect to t at t equal to 0. One time derivative. So mean x bar equal to its first derivative n into q plus p e power t whole power n minus 1. After that, inside the bracket, when you differentiate with respect to t, p e power t comes again. So we have to substitute t equal to 0 finally, no? So it comes as np. This term t equal to 0, q plus p is 1, 1 power anything is 1. Here e power 0 is 1. np is the mean of the binomial distribution. Variance of x is mu2 dash minus mu1 dash the whole square. Mu1 dash the whole square, where mu2 dash equal to mx double dash of t at t equal to 0. Okay. So here we can find mu2 dash by differentiating this one more time. Okay, so here n is constant. When we consider p e power t is constant, this becomes n minus 1 q plus p e power t whole power n minus 2 into p e power t plus ub formula. When you consider q plus p e power t whole power n minus 1 is constant, p e power t comes as the derivative. That is equal to, we have to substitute t equal to 0. So that We can find mu2 dash equal to NP plus n into n minus 1. Here it comes as n is outside. So n minus 1 p square. Now variance of x equal to np plus n p squared n into n minus 1. Okay, so what we can write it as n squared p squared minus np squared minus n squared p squared. So these two things are cancelled. When you take np outside, 1 minus p can write. This is nothing but npq. So the variance is np. And obviously the standard deviation is nothing but square root of variance equal to square root of pq n npq. These are all the derivatives. Remaining the problem we can see it in next video.